1.
So the question I asked you guys, is dissolving salt a chemical reaction or not? Now, hopefully you guys wrote your predictions down, and I would assume by most of your guys' prior knowledge from classification of matter, most of you probably said it wasn't. It wasn't a chemical reaction. We don't see the things that we typically see where we have a temperature change necessarily. We don't have bubbles. We don't have a gas being produced, which creates the bubbles. We don't have a change in pH, all that kind of stuff. You might have said that. However, based on the chemical formula, it actually is a chemical reaction. And I'm going to prove that to you right here. Now, before I do that, I know some of you are pretty defensive right now. Like, well, dissolving is not usually a chemical change. It's a physical change because we can use evaporation typically to get out the salt from the water. So we can evaporate the water off. That's a physical separation method. And I totally agree with you. And that's why this is a really hot topic. There's a lot of people that go back and forth on this. But ultimately, it comes down to the equation and the chemical equation. So if we look at the chemical equation on your screen, we have sodium chloride, which is a solid. That is your salt, plus water, which is H2O, which is a liquid. That's what this L stands for. When those combine, the water dissolves. And that forms sodium ions. Okay, that's what that means. Chlorine ions, which are specifically chloride. And the AQ means aqueous. That just means dissolved in water, pretty much. So it's a water solution. And then also we have water left over. So we have now what the water has done, it has split apart the sodium chloride to make sodium ions and chlorine ions. So that's what we have. And that equation, if we can see, this is different from what we have over here. Yes, the water is the same, and that can happen, but sodium chloride is not the same thing as sodium ions and chlorine ions. This is bonded, this is not. So we've broken a bond, and that's a part of the idea of chemical reactions. If you break a bond, you are going to have completely different substance. So I'm going to show you this reaction right now. I have the supplies. Now, first, I do want to show you water. This is distilled water. Okay, so distilled water actually is not a good conductor because there is nothing to transfer the electrons from one place to another. Now, before I do this, I do want to show you that the circuit works. Okay, so the light bulb turns on. Now, when I put this in water, I'm not going to touch the wires, but I'm just going to put both of the wires in water. And ultimately, it should connect if this wasn't distilled. Okay? Because distilled water is pure, there's nothing to transfer the electrons. Therefore, pure distilled water is actually a good insulator. Okay. Now, what we'll do is we are going to pour some of our salt in here. And when I dump salt in, you guys have dissolved salt in water before. We're not seeing any drastic chemical reaction going on because, again, typically we don't think of this as a chemical reaction. We just have the salt dissolving in the water. Nothing drastic happening, no gas bubbles, no odor, no nothing like that. However, this water has now broken apart your sodium chloride to make ions. So ultimately right now we have all of these charged particles everywhere in here. So it should be able to carry electricity through, the electrons through. So let's see here. While it might be faint, it should work. Okay, let's try it again. One more time. Let's see. Of course, it's not working. Let me try it one more time. There we go. Okay, so we can see that it transfers through the ions and it then creates the complete circuit. So this is just one more way to prove that what we had to start with is different from what we had to end with. Okay, again, proving that we have this idea that we have a new substance, therefore it is a chemical reaction. So yes, dissolving salt in water technically is a chemical reaction.